Okay, here we have a new graph. And let's see if we can walk through some steps to find its slope. So what we did before is we thought about how much does my output change based on 1 unit change of input. Well, if I look at this, the first thing that I notice is my graph appears to be going down from left to right. So as I move from left to right, it appears that my graph is going down. So that means as my inputs increase, if my input increases by 1, I will have less output. So I should expect that the slope of this graph is negative. So let's go around and let's see if we can find some nice points on this graph. If I look around, what I see is I do have what seems to be a nice point right here at the point 0.04. So let's go ahead and let's think to ourselves, what happens if I have 1 unit increase in my input? So if I have this increasing my input by 1, I would have to go over by 1, and I'll see where do I end up with my outputs. So I don't know exactly what that output is. It looks like it's somewhere between 2 and 3. It's probably about 2.5. I'm not quite sure. Let's go ahead and let's see if we can estimate what happens here. So increasing my input by 1 right here, so this was plus 1, caused my output to go down by how much? By about 1.5, it looks like, by about 1.5. So if we think about this again, my slope, my m, would be rise over run. Okay, slope is rise over run. And if I plug these in, rise would be how much do my outputs change. So I'd say this is a negative 1.5. And I'm going to divide this by how much my input changed. That was my run, which is 1. And it looks like we would get a negative 1.5 for our slope. Well, this seems pretty accurate. So if I went over by 1, I would go down by 1.5. But I had this problem where, well, I kind of estimated what this was. So what I would like is maybe I can pick a different point. Maybe I can go ahead and find another nice point. So this point here was particularly nice because the coordinates were 0, 4. So let's take a step back. I'm going to erase everything here. And I'm going to see if I can pick some new points, or 2 nice points. So let's go ahead, and this was a nice point, so I'm going to keep this one. And if I look around, as I move along, I wonder to myself, is there some other nice points that I hit? And it looks like this one down here is pretty nice. Input of 2 corresponds to an output of 1. All right, so let's go ahead and let's mark that point and see if we can make something happen out of this. So rise over run. So first I want to say how much does my output change? And we come over here. We're using green for that. So it looks like my outputs are this, right? So from here to here, all of this is my change in output between these 2 points. And 4 to 1, so I would go down. So I would go down 1, 2, 3. So it looks like my output, my change in output is minus 3. What's my change in input? So if I look at the change in my x coordinates, that would be this here. And we were at 0, and now we're at 2. So it looks like that change is a change of plus 2. Okay. Now slope. We said slope was equal to rise over run, or the change in y over the change in x. And so my change in y was -3, and my change in x was a +2. And so this right here, -3 over 2, it turns out to be -3/2, and we're familiar with that is 1.5. -1.5 is our slope, or -3/2. So this is another example. So if we're going to find the slope of a line graphically, often what we do is we find 2 points and we ask, how much does my output change between them? So we look at our change in y, and then we find how much our input changes. We look at our change in x, and when we divide them, change in y over change in x, that gives us our slope. See you next time.